All right, so the next topic that we're covering is trig functions and sign changes. So we're still working with trig functions, but now we're going to see how their signs change depending on what quadrant we're in. So I do have my delta math calculator here that we're going to use just to input these into our calculator. So sine of 48 degrees. If we were to draw a sine of 48 degrees, it would end up being in quadrant 1. Okay. Just make like a little graph right here because from here to here, 0 to 90, it would end up right here. Okay, so when I punch this in my calculator, remember when we're putting this in our calculator? Well, I don't know what this is. Okay. We need to make sure that our graph or our calculator is in degrees. So my degrees is highlighted in green. And I just need to punch in sine of 48. Okay, so it gives me 0.74. So 0.74. Okay. And I have tangent of 194. So I'm going to go ahead and do the same. I press functions, tangent of 194. Enter, that gives me 0.249. So 0.249. And so if we were to graph tangent of 194, it will, right here is 180 and right here is 270. So that means it would land in quadrant 3. Okay. Then the next one, we have cotangent. So unfortunately on our delta math, we do not have the cotangent button. So what we do is, because cotangent is the opposite of tangent, we do 1 divided by, and then on here we're going to put tangent of 110. Okay, so that means the same thing. This gives us negative 0.36, negative 0.36, go 3 decimal places, so 364. And so here, 110 would land right here in the second quadrant because this number is 90 up here, and this number is 180. So this would be in the second. All right, so then looking at the other ones on this side, we have cosine of 136. So here we have function. I'm going to punch in cosine of 136. That gives me negative 0.719. Negative 0.719. So if I were to draw a picture, it would land between 90 degrees and 180 degrees. That's where 136 would land, so it is in quadrant 2. Then we have cosecant of 285. 285 would land in, let's see, quadrant, this is 180, this is 270, so it's actually more than 270. It would land in quadrant 4. Okay, so quadrant 4. And when we punch that in our calculator, cosecant is the opposite of sine. So here, we're going to do 1 divided by, and we're going to use the sine of 285. Enter, gives me negative 1.03. Negative 1.035. And then the last one is secant of 320 degrees. So the opposite of secant is cosine. So 1 divided by function cosine of 320. Enter, and it gives you 1.305. 1.305, and this one, 320, is going to land in quadrant 4 because 270 to 360 is our quadrant 4. Okay, so then from here, let's see, as you can see, the trigonometric functions can have a positive or a negative value. The position of the terminal side of an angle determines the sign of the various trig functions of that. Okay, so for example, in our first quadrant, our x value and our y values are positive on this side. So my x value and my y value is positive. So when we're making our ratios, our O over A, H over O, or whatever it is, all of our signs are going to be positive. So if you notice here, it says all are positive. Okay, so that means sine would be positive, cosine would be positive, and tangent would be positive. Okay, so if sine is positive, its opposite is also positive. So cosecant is positive. If cosine is positive, then secant is also positive, and if tangent is positive, then cotangent is also positive. Okay. Then moving into the second quadrant. So when we move into the second quadrant, our x value is negative, but our y value is positive. Okay? And so when we're making our ratios, the only signs that are going to be positive is our sine and our cosecant. So those are the only trig functions that will be positive. So on here, if I put my positives, it's sine and its opposite, cosecant, are both positive. The rest of them are going to be negative. Okay. And then in our third quadrant, the only ones that are going to be positive are going to be tangent and cotangent. Okay. So tangent and cotangent will be the only positive ones. And the rest of our trig functions will be a negative value. So it doesn't matter, as long as the angle lands somewhere in the third quadrant, only the tangent and the cotangent will be positive, the other trig functions will be negative. And then last, in the fourth quadrant, the only ones that are going to be positive are cosine and secant. Okay? And the rest of them are going to be negative. So cosine and secant are positive, and the rest of them will be negative. So the way that we remember this, and there's like a little acronym that we use, it's all students take calculus. So that's how we memorize it. All of them will be positive in the first. So S stands for sine, T stands for tangent, and cosine starts with a C. So if you guys want to use that to memorize it, or you memorize this little table with the positives and the negatives, then that's okay too. Okay, so on the first one, it says, in which quadrant is angle theta if cosine of theta is negative and sine of theta is positive? Okay, so we're going to look for when cosine is negative. So cosine is negative here and here. The other two quadrants, it's positive, okay? Then we're going to go ahead and check. So this is in the second and the third quadrant. And then where is sine positive? So we're going to look for where sine is positive. So sine is positive in the first quadrant and in the second quadrant. Okay, so the one that has both of them, because it says cosine is negative and sine is positive, is this quadrant right here. That's the one that has both of them. So here we're just going to put quadrant 2. Okay, that's the one that they have in common. All right, so let me erase that one, and let's look at the next problem. So here now we're looking for when cosine and tangent have the same sign. Cosine and tangent have the same sign. So here we have two possibilities. Either they're both positive, so we're looking for when cosine and tangent are both positive, or they're both negative. Okay, so we're going to look for when cosine and tangent are both negative. So if we're looking here, first we're going to look for where they're positive. So they're both positive. Cosine and tangent are both positive in this quadrant. I think that's the only quadrant where they're both positive. And then where they're both negative would be in the second quadrant. In the other quadrants, they're opposite signs. You can see here they're opposite signs. Okay, so then this one, they have the same sign in quadrant 1 and quadrant 2. This. Okay, the next one, we're looking for when tangent of theta is greater than 0. Okay, so when we're looking for tangent of theta is greater than 0, that is a fancy way of saying the tangent is positive. Okay, because all the numbers greater than 0 are positive. And then this one that's saying sine of theta is less than 0, that is a fancy way of saying sine is a negative number. Okay. So we're going to look for where tangent is positive and sine is negative. So when we're looking for where tangent is positive, it's positive here and here. But then sine is negative here and here. So the one that satisfies both conditions would be the ones in quadrant 3. So that would be your answer here, quadrant 3. Okay, so, whoops. Just erase what I just did for this problem. Moving on to the next one, we're looking for when cosecant of theta is less than 0. So again, when we say cosecant of theta is less than 0, it's a fancy way of saying that cosine is negative, because all the numbers less than 0 are negative. And then we're looking for when secant is greater than 0. So greater than is a fancy way of saying secant is positive. Okay, so first I'm going to look for where cosecant is negative. So cosecant is negative here and here. And then secant is positive, so I'm looking for when secant's positive. Secant's positive here and here. So the one that satisfies, or the quadrant that satisfies both conditions, is going to be quadrant 4. So right here, I'm just going to put a 4. All right, let me erase this part. Moving on to the next section. It says cotangent and secant have opposite signs. Okay, so we're looking for when cotangent is positive and secant is negative, or the other way around, when cotangent is negative and secant is positive. So first I'm going to look for where cotangent is positive, but secant is negative. Okay, so if we look in the first quadrant, here is cotangent and here's secant. They have the same signs, so that's not what I'm looking for. Okay, here's secant and cotangent. They have the same sign. They're both negative, so that's not what I'm looking for. Here, secant is negative and cotangent's positive, so there's one of them. And then here, secant's positive and cotangent is negative, so they have opposite signs. So this happens in not only quadrant 3, but also quadrant 4. All right, the next one says cosine of theta and cosecant of theta have the same sign. So if they have the same sign, we have the two possibilities. Either they're both positive, okay, which cosine and cosecant are both positive in quadrant 1. So that's one of our options. And our other option is going to be when they're both negative. Okay, so if I look for where cosecant and cosine are both negative, it would be in quadrant 3. And 1, 2, 3. All right. So here on the next section, it says find the exact values of the other 5 trig functions for an angle, theta, and standard position given the following. Leave your answer in simplest radical form when applicable. Okay, so starting off here, I'm going to make my graph real quick. And then we're going to figure out what quadrant we're in. So here it says it has to be between 3 pi over 2 and 2 pi. So this is 0. This is half a pi. This is 1 pi. This is 3 pi over 2. And then this is 2 pi. Okay, which means that our triangle is going to be right here because they tell us that in this section. Okay. And then from there, it tells us that sine of theta is negative 5 over 13. So let's see, this is my angle theta. Sine is your opposite over your hypotenuse, so that means that my opposite is 5, so this one's 5. And then 13 is my hypotenuse. Okay. Now the 5 is going to be negative because it does go down. So here I'm just going to fill this in. Sine is negative 5 over 13, so that means that cosecant is going to be 13 over 5, and it's negative also. Then we need to figure out the rest of the trig values, so I need to find this missing side right here. So I'm going to go ahead and do a squared plus b squared equals c squared. So negative 5 squared plus b squared equals 13 squared. And we're going to solve for b, so this gives me 25. This gives me 169. I subtract the 25. And this gives me b squared equals 144. I take the square root, and b gives me 12. So this side is 12. Okay. This is my adjacent side, this is my opposite side, and this is my hypotenuse. So we're going to do SOHCAHTOA. So cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, so this means that our cosine function is going to be 12 over 13. Secant will be 13 over 12. Okay. My tangent is going to be opposite, which is negative 5 over my adjacent, which is 12, and then my cotangent is going to be negative 12 over 5. And as you notice, the only one that comes out positive is my cosine function. And it's opposite. All right. And the last one. So here it says secant of theta is -2. So I'm going to go ahead and fill that in real quick. Secant here is -2. Okay, which makes cosine -1/2. I just flip it over. Still has the same sign. So I'm going to go ahead and draw my graph. Now this time it tells me that it needs to be, or my triangle needs to be between pi and 2 pi. Okay, so it's either right here, triangle theta, or right here. Okay, so the other information that we need to use is the fact that secant or cosine is negative. Okay, so either it's negative here or here. Okay, so just based off of the notes that we just took, it is negative in the third quadrant. So that means that it has to be this triangle on this side. Okay. So now that we have our triangle, we know our cosine is adjacent over hypotenuse, which means that my adjacent side here is 1, and it's going to be -1 because my x values are negative on that side, and then this is my hypotenuse, which is 2. So we're going to use a squared plus b squared equals c squared to find my missing side. So we have -1 squared plus b squared equals 2 squared. Okay, this gives me 1 plus b squared equals 4. We subtract the 1, and we get b squared equals 3. We take the square root, and since we're leaving it in simplest radical form, we need to leave it as a square root of 3. Okay, so this is my opposite, this is my adjacent, this is my hypotenuse. So my sine function is opposite over hypotenuse. So my opposite happens to be the square root of 3, and my hypotenuse is 2. Okay, I'm going to go ahead and flip that for my cosecant, so it'll be 2 divided by the square root of 3. And remember, we can't have a squared on the bottom, so we're going to have to rationalize it. We have to multiply the top and the bottom by the square root of 3, and it gives me 2 and the square root of 3 over 3. For the tangent, our tangent is going to be opposite over adjacent. Okay, so opposite is the square root of 3, and my adjacent side is -1. Okay, so if we simplify this, this would just be the negative square root of 3. But when we take the square root of 3 over -1, we flip it for cotangent, and it's -1 over the square root of 3. Now again, we're going to have to rationalize that one because we can't have a square root on the denominator, so I'm going to have to multiply the top and the bottom by the square root of 3. And this gives me the negative square root of 3 over 3. And that's it. Thank you guys. Bye.